Okay, another little follow-up to Zeno's paradox. When we talked about this model of going from school home and not being able to get home because before you get home you have to pass that halfway point, then that one, that one, that one, so on and so forth. And since that line is infinitely subdivisible, there's no way for you to get home because you can never get through that last halfway point. It doesn't exist. So we kind of reasoned this way. These numbers must add up to 1 because you know you do get home from school. But in mathematics, we don't quite say it that way. What we say is that this limit, as n goes to infinity, of this series right here, 1 over 2, 1 over 4, 1 over 8, so on and so forth, up to 1 over 2 to the n, as n goes to infinity, this thing right here converges to 1. So that's what we say. We don't actually say that these numbers add up to 1. We say that this series right here converges to 1 as n gets very large. Another way to write that with the summation notation, which you learn like in college algebra, intermediate algebra, would be this. And then here, this is this limit, which we learned in calculus. The limit as n goes to infinity of the sum of all these terms from 1 up to n. As n goes to infinity, that comes out to be 1. So you look at this and you say to yourself, well, you know, so what? I know that this is going to add up to 1. Look, these are getting smaller and smaller. You keep adding less and less on. It has to add up to something. But that's not the case. Look at this series right here. 1/2 plus 1/3 plus 1/4, so on and so forth. Just the reciprocals of the whole numbers, that does not converge. You can add these up and get that to be larger than any number you can name. So the limit as n goes to infinity of this series right here, 1/2 plus 1/3 plus 1/4 up to 1 over n, as n goes to infinity, that diverges. It becomes infinite. So there's no limit to how large that sum can be. So when you think, well, I'm just adding up these little fractions and stuff, it has to add up to something, that's not necessarily true. This right here converges to 1, and we can show that in calculus by using some definitions for the limits. Likewise, we can show that this diverges and becomes as large as you want it to be, just depending on how far you want to go down that series. So there's a little bit more to it than you might think when you first see this, but that's a little extension of our work with Zeno's paradox.